All right, so we're changing gears a little bit. Our last two sections that we're doing inside of Unit 1 are going to be about equations. We have a quiz coming up as well next Tuesday, just to be on your radar over these last three sections. So 110 that you just finished about radicals, and then two sections about equations. And again, if my other class is any indication, they did in fact like this lesson better. So that's always good when there's some light at the end of the section of material. So we're taking a look today at equations, and to start with, we're going to take a look at what it means to solve. So solving equations is built around the idea of inverse operations. That is to say, we want to undo all operations until we have the variable alone on one side of the equation. So we're going to start this section with several different types of equations that we could call one-step equations. There's only one operation we need to do in order to isolate or to get x alone on one side of the equation, or whatever variable it is. So we're going to start with one-step equations. So here's our first one, number 1. We have x plus 3.2 equals 4.6. And we see that the x is grouped with addition and a value. And so we're going to think about what is the inverse operation for adding 3.2, and that would be? What's the opposite? Yep, subtracting 3.2. So we are going to do the opposite operation to both sides of our equation. We will subtract our 3.2. Positive 3.2 and negative 3.2 add to 0, which is the whole point. Right? That's why we did what we did. That leaves us with x on the left. And what is 4.6 minus 3.2? 1.4. They're over here. The idea of inverse. We want to undo all the operations until we have the variable alone. Yep. Okay, so we're undoing operations where we're doing inverses. It doesn't matter whether the variable is located on the left-hand side or the right-hand side to be alone. So as we're looking at this 5 equals y minus 8, if it really bothers you that the y is on the right-hand side, you're welcome to rewrite this as y minus 8 equals 5. That's fine. So definitely not necessary, but you could if you'd like. I'll leave mine as it is. Right now, our y currently has an 8 subtracted from it. So what is the opposite of subtraction of 8? Addition. So we will add 8 to both sides of our equation. 5 plus 8 is 13. Of course, on the right-hand side, the positive 8, the negative 8 out to 0, which was why we chose it. And we have y. So 13 equals y, or if you prefer, you can write y equals 13. Okay, any questions so far? Okay, so if we have addition, we're going to subtract. If we have subtraction, we're going to add. Opposite operations. So we should be able to do this with all types of values. It's nothing special about whole numbers, which is what we did on problem number 2, or decimals, which we did on problem number 1. Fractions work the same way. So right now, on the left-hand side of the equation, we have our z, and it currently has a 2 over 3 being added to the z, right? Those are addition. What is the opposite of addition? Subtraction. So the way that we are going to undo or move the 2/3 is using subtraction. Now, on the left-hand side, of course, this is 0, right? That's why we chose it, and we're left with the value of z. Over on the right-hand side, and I'll just do a little scratch work off the side, we have 3/2 minus 2/3. And we had 2 sections of material talking about fractions early on this semester. What do we have to do in order to add or subtract fractions? Yeah, we need common denominators. So we had one method where we kind of did this one that looked like a smiley face, right, to find our common denominators. We had also the idea of just taking a look at the 2 and the 3 and asking what's their least common denominator or a common denominator if we don't want to do the least common one. So would you like to do the one where I did my crosses and the smiley face, or do you want to do it with least common, the way it was? All right, it is 6, yeah. So if I were to multiply this 2 by 3, top and bottom, and multiply this 3 by 2, top and bottom, I would achieve that 6 that you mentioned a moment ago. So that gives me 3 times 3 is 9 over 6, minus 2 times 2 is 4 over 6. And if we subtract those, we will get, yes, it's early, isn't it? 5 over 6, that's right. So over here, my z equals 5 over 6. You're welcome to do this work inside of the actual, equation problem we're doing if that is where you'd like to do it, or you're welcome to do it sort of on the side of your paper to find that value too. Either way is fine with me. 5 over 6. Okay, so any questions on the fraction piece? All right. Number 4 is a little bit different. So 1, 2, and 3 all involved addition or subtraction, but number 4 does not have any addition or subtraction involved. How are the 4 and the u attached or combined? They're combined with multiplication. So what is the inverse? You got it. So Malik says we're going to divide, and he's exactly right. So the inverse operation of multiplication is division. And of course, the reason we have this now is because 4u divided by 4 would simply be u. And then we have 18 over 4, and there's a couple of different things that you could do. So you can't, well, what you can't do is just leave it as 18 over 4. That would not be reduced or simplified. So one option is that you could leave it in fraction form and recognize that they both divide by 2 and end up with getting 9/2. Yes, on this one you can. So another option on this one is if you wanted to put it into decimal form. Do you have, Malik, the value for the decimal? Can you tell? It is 4.5. That will work just fine for this one. And I'm fine with you putting it in decimal form as long as you actually have a terminating, a stopping decimal. But if you had, for instance, at the end here, 5 over 6, like we had a minute ago, like right up here, and you put this in decimal form, tell me what your calculator tells you 5 over 6 is in decimal form, just for fun. 0.83 repeating, right? Yeah, repeating decimals aren't so great. We're not going to leave them in a repeating decimal form. We're going to either leave them in a fractional form if that happens, or we're allowed to change them into decimals if that doesn't happen. Okay, that's going to be our rule of thumb. All right, so we don't want to do a repeating decimal answer, but we would be fine with a regular terminating decimal, not regular, but a terminating decimal type answer. Okay, so if we have multiplication, we can use division. How about number 5? What do you see? Right, you got it. So we see division, and the opposite of division is multiplication. So we're going to multiply by 7 on both sides. Multiplying, dividing here gives me x, and on the right I get 28. Any questions on that one? So what happens on 6 that's a little bit different than the ones we've seen before? There's a negative. There's also a decimal. With division, we haven't had a decimal actually occur within the problem. That's true for a division problem. So the negative 2, and the x are being multiplied, right? So how will I do what is the inverse operation of multiplication? Yeah, so the negative 2 just means I'm going to end up dividing by a negative 2. The negative doesn't affect anything in terms of the operation I choose. I am left with, because these cancel, an x on the left. And then 3.8 over 2 does divide nicely because I'm dividing by 2. So what is 3.8 divided by negative 2? Yeah, and it makes sense that this would be in a decimal form answer because the question began in a decimal type question. Okay? So we have negative 1.9 on that one. Any questions on anything from 1 through 6? So So if it's addition, we subtract. If it's subtraction, we add. If it's multiplication, we divide. And if it's division, we multiply. Now, I mentioned when we first started that those were all one-step equations, right? You did one thing and you were done. But not all equations have that feature. Some need more than one step before they're done. So these are at least two-step equations we're going to take a look at on the rest of our problems for today. Number 7 has a couple of different things we could do. So I'm going to let you tell me from what you remember, what would you maybe want to do on this problem as your first step? Okay, say something really loud for me, Avery. Okay, how would you move it? Awesome. So while I know there's a subtraction sign here, that negative is associated with x. The sign in front of the 4 is addition, right? It's a positive. So you're exactly right. We're going to subtract the 4 to the right. Now, I'm going to show you another way to do the problem in a second. If this is not what you thought of as your first step, hold tight. We'll examine another possibility in a moment. So this is 4 and negative 4, leaving me with negative x equals, and what's 7 minus 4? 3. Now, it almost looks like x is alone, but it still has a negative on it, so it's actually not alone yet. How would I deal with the negative? You could divide by negative 1. You could also multiply by negative 1, and it would achieve the same goal. I would end up getting x equal negative 3. Okay, so this is one approach to this problem. Did anybody else think to do something else differently when they first looked at this? Okay. Let me show you another option. If you don't like my option, that's fine. You can use first one. It works just great. Sometimes people don't like the negative x and they deal with it instead of using multiplication or division by simply moving it to the other side itself. And they could add x to the other side. So there's a 4 here. Our addition and subtraction of x's cancel out. And I've sort of regrouped where the x is located. It's still attached to something, in this case with addition, to the 7. But we do, in fact, now have a positive value or a positive sign on the x. And then our second step would be the subtraction of the 7 then. So I would end up with x on the right-hand side, and then 4 minus 7 on the left would give me that same negative 3. So I don't end up dividing or multiplying by anything on that one because I've done something else in a slightly different way. But I will achieve the same answer. Okay? So it doesn't matter to me how you want to approach the problem. You have choices. How about number 8? What seems like a natural place to start first? Yeah, so normally, especially when there's no negative involved, sort of throwing us off a little bit like the last one had the option to do, we will tend to start the furthest away from x and we will work in to try to isolate the x. The 2 is further away in terms of how it's being operated on by the x than the 6. So we could subtract the 2 first to eliminate that because of that. So I have positive 2 and negative 2. Those add to 0. 14 minus 2. 12. Yeah. Now what? Yeah, the 6 and the x are multiplied, so we'll divide by 6. So what is 12 divided by 6? It's 2. And we have x is 2. So I'd like to pause right here and just make a reminder. We've talked about this already in a previous lesson, but the way that we're doing these worksheets, this class, you don't have a back of the book to check your answers, right? So let's say you got to the end of this problem and Caleb has x equals 2 and Gracie has x equals 3 and they're not sure who's right. And they look at their work and they're still not figuring out where they went wrong or whatever. They just want to know which one's actually the right answers. What could you do to check to make sure that the answer you got, whatever it was at the end, actually works? Put it where the x is. And what equation, Abby?
I was looking number 8.
So like in the original equation you were given, right? Yeah, so if you were to take the original equation you were given and you were to substitute it in, evaluate it in for the x value, we got 2. We could check to make sure, sorry, this is running out a little bit of space. Let me shift it down a little bit. We could check to make sure that it does in fact equal, sort of like a question mark, does it really equal 14 when I do that, right? Well, 6 times 2 is 12, plus 2 is 14. So sure enough, 14 does in fact equal 14. And so even without, a back of the book, so to speak, I can check and make sure that my answer is correct pretty quickly. And you're welcome even to just check that step in your calculator if you would like, just to make sure that as you get to the final answer that you ended up with the correct final answer. All right. Number 9 is another place where we actually have a couple of options of how we deal with it. So as you see number 9, what would you think to do as your first step? So distribute or expand. Yeah, so we could distribute this through. That is definitely one option. So this would give me 3w minus my 21. And if I do that step, it actually becomes just a lot like the other problem that I just did, right? So what would be my next step? Add 21. Okay, so now I have 3w equals, what's 18 plus 21? It is 39. Now what? Divide by 3. And I would get that w equals 13. Very good. W equals 13. So this, I think, is probably the most common way that students will tell me how to work this problem. There is another option. Did anybody think of a different option that they could do for this problem when they first saw it, or maybe as you're thinking about it now? Say it really loud, Avery. Yeah, so the 3 on the outside means it's being multiplied by the stuff in parentheses, right? So the inverse of multiplication is division. So instead of actually distributing it through, we could actually divide by 3. And that eliminates the multiplication division by 3 over here. So that works really great when the number on the other side divides evenly by it. Often that will work. It doesn't always, but often it will work on the problems that we're looking at. That leaves me with w minus 7 on the left, and what's 18 divided by 3? 6. So what would be my next step then? To add the 7. And do you notice you get the same answer, right? So again, there are sometimes options of what actually makes sense in a particular problem to do, and this would be another option that would achieve the same goal. It would be correct. Okay? So if I just confused you with the other process, I'm really sorry. I didn't mean to. Just ignore it and go back to the one you liked the better way. Okay? But they're both valid options. Number 10 has a typo. That is to say, there's just not enough information written down here. That's my fault. It didn't get into the notes quite right. This is correct, but there's also supposed to be another line that says y equals 7. Okay? So just write it on there. That should be like typed in your book already, but it just got left out accidentally. So it should say z equals 4y and y equals 7. Both those pieces. So there's a couple problems that you're going to have on the homework assignment today that'll start out looking like this, where they give you sort of 2 equations. The second one, it is technically equation, but it's also just a value that y is equal to. I get that. And what it's wanting you to do is it's wanting you to solve for z, right? So you're going to take the equation for z, and you're going to evaluate in, kind of like we were doing over here when we did our check step to make sure that it actually worked. You're going to evaluate in 7 for the y, like so. And then simplify anything you're able to simplify. On this one, of course, 4 times 7 is 28. So you're done, and you found that z equals 28 with the conditions that you were given. Okay? Any questions on that one?
Oh, just like in general, like when you're doing homework.
Mm-hmm.
So let's say you're writing it so that z equals 4 times 7 and z equals 28. You have to rewrite it to clearly state that z equals 28, or will the working show something?
So I think what you're asking me is if you were to say stop right here, would that be okay?
Yeah.
That would be okay. Yeah, just make sure it's very clear. Sometimes I have students who write things, but they don't put equals between everything, so then it's not very clear. So just be really clear in your work with the notation you're using, what you're intending it to mean. Yeah. Okay, any questions about those sets of problems? Awesome. Let's go ahead and grab out then number 11, homework number 11, and start taking a look. I will be filtering around to answer questions as needed.